Should we start? Start कर. Good afternoon to all. Warm welcome to all of you. Respected Director Dr. Rajiv Khatri sir and HOD CSE Saurabh Sharma sir and HOD IT Vishal Pranjapi sir and our HR Niharika ma'am and dear participants and my colleagues and students. We are happy to organize this FDP development program on deep learning and its application in emerging fields. This is a 8-day FDP where we learn fundamentals of deep learning techniques and its application in the different emerging fields. We believe that this FDP will help the participant to learn basics of deep learning techniques and their application in different emerging fields. We are fortunate to get a good panel of experts from IITs, IIITs, and NITs. They have several years of experience in this domain, having published research papers, international journals, and conference of repute. These distinguished teachers, with their immense knowledge and experience, will guide us through this faculty development program, providing valuable insights, practical guidance, and inspiring us to excel in the field of deep learning. Now I request to our director, Dr. Rajiv Khatri sir, to address this event with his enlightening words about our institute. Sir, please.
Yes, a very good afternoon to all of you. Honorable guest of today's online function, Dr. Venkata Naresh Babu from NIT Goa, all the plenary speakers, delegates from industry and academia who have joined online, my colleague, faculty members, and dear students. First of all, on behalf of Baridia Global Group of Institutions, I welcome you all to this 7 days the International FDP and workshop on deep learning and its applications in emerging fields at Global. In light of the liberal economic and industrial policy adopted by the Government of India, the industrial scenario is fast changing. The world is now compelled to adopt digitalization and use of new and advanced technologies of computer science and artificial intelligence in all the fields. Deep learning is a method in artificial intelligence that teaches computers to process data in a way that is inspired by the human brain. Deep learning models can recognize complex patterns in pictures, text, sounds, and other data to produce accurate insight and predictions. In line with this FDP is being organized, and I am sure that this FDP will be an event that bring people from industry and academia together for the mutual support, education, and inspirations, focusing on the development of an environment for the exchange of ideas towards technological developments for the benefit of students and society at large. The plenary speeches by the experts on new technologies of computer from IIT Guwahati, IISc Bangalore, IIT Roper on recent deep learning models for computer vision and various applications of deep learning, IPR, and other advanced research topics in AI, data mining, machine learning, etc., will definitely throw new light on the developments in this field. I highly appreciate the efforts of the whole of the organizing team under Professor Saurabh Sharma and Professor Vishal Paranjpe, Head of Department of CSE and IT, and Dr. Mamta Samal for taking initiative in organizing this conference. Efforts of all the faculty members and the students are also appreciated for their proactive participation. I extend my sincere gratitude to Dr. Babu for accepting our invitation to enlighten, motivate, and bless our faculty and students at this occasion. I once again welcome you all to this interactive FDP program and wish you grand success for the program. Thank you. Jai Hind.
Thank you, sir.
Thank you so much, sir, for your encouraging words. Now, I would like to thank our partner for providing Mr. Saurabh Badadia, sir, for providing us all necessary support to organizing this FDP. I also thank our director, Dr. Rajiv Khatri, sir, for always encouraging us to organizing such programs. I also thank HOD CSE, Professor Sarma, and HOD IT Professor Bisal sir for extending all their supports and encouragement. I also thank all my colleagues for their constant support whenever needed. Lots of thanks to all the experts for giving their valuable time for delivering lectures. Thank you all once again. Our first speaker is Dr. Venkat Naresh Babu from NIT Goa, who is with us. Now I request Professor Neha ma'am to give a brief introduction about them. Over to you, ma'am.
It's my distinct pleasure to introduce our esteemed guest for today, Dr. Venkat Naresh Babu sir. The stellar academic journey that includes a master's and doctorate from prestigious IIT Delhi, as and as an IEEE senior member, Dr. Venkat Naresh Babu sir underscores his contribution to the field and commitment to advancing the frontiers of knowledge. His professional journey has been marked by a multitude of projects, with a notable mention of collaboration with SCRB and international partnerships, including noteworthy collaboration with Indo-Norway. Currently, Dr. Venkat Naresh Babu sir is driving force in Department of Computer Science and Engineering at NIT Goa, shaping the next generation of professionals and contributing to academic and research landscape. So once again, on behalf of Padelia Global Institute of Engineering and Management, join me in extending a warm welcome to Dr. Venkat Naresh Babu sir. We look forward to gaining insights into his wealth of knowledge and experiences on deep learning. Now, I request Dr. Venkat Naresh Babu sir to enlighten us with his words. Thank you. Sir, please.
Okay, thank you, ma'am. Thank you. Is the screen is visible, madam?
Yes, sir. It is visible, sir.
Okay, ma'am. Sure.
Sir, please make it full screen.
Okay, ma'am. So, Just 1 minute. So today we are going to discuss about completely introduction to deep learning. Okay,
Yes,
how
sir.
how the research um, has been moved from artificial neural network to deep learning. Okay, so in between, so I promise everyone, once you just follow me with my lecture, you just follow me, you will understand what is deep learning. And definitely rest of the lectures from tomorrow onwards in this FDP, first lecture is the most important lecture. In this lecture I am going to deliver all the required things which are useful in the next lectures for you. Okay.
Sir, excuse me, sir. Sir, please, uh,
Yes,
uh,
madam.
make it full screen.
I already kept a full screen, madam.
So it is not coming. Can,
Okay, that means okay, okay, I will open PDF. Maybe it is not coming. One
okay,
minute.
okay.
Okay, so I hope this screen is okay, madam.
Yes, sir. It is okay. Fine.
Okay, okay, madam. So this is we are going to learn all the uh, deep learning and its applications. Now let us understand basically. See, the word deep learning, whenever many people see, no, first they will get afraid of the word what is deep learning. Okay, it must be so difficult. No, it is very easy. There are just 5 algorithms are there. I'm going to explain you in detail those algorithms. Once you understand them, then easily you will understand what is this deep learning. Okay, I will make you very easy. Okay, deep learning. Okay, now let us see. First we will start with the basics from where everything started. We know that, I think many times we have studied um, in our, I think, lower classes, that what is a neuron. Okay, neuron means basically smallest cell in the brain is a muscle, right? In that muscle there is a smallest cell. That cell is neuron. Okay, the neuron structure looks like this. You can see here the neuron structure. Now these are called, these edges are there, no, those are called dendrites. And this is called nucleus. Okay, and this is called cell body. And this is called axon, and these are called axon terminals, you can see here. So this is a cell. Okay, this is a neuron. Okay, neuron looks like this. So basically if you say something is a neuron, it receives the information through this dendrites, and the information goes through nucleus. Okay, then this is processed here, then the output will travel through axon. So this is how this neuron works. Okay, so basically when you want to do modeling, generally mathematicians what they do, they want to do modeling, they construct a similar structure. Okay, so I am constructing, see here there is a similar structure I'm taking. Then I'm taking input 1, input 2, input 3. In the same way how there are dendrites, now you can see here there are dendrites. Okay, they receive the information. Similarly here there is a neuron receives input 1, input 2, and so on, input n. And this, all this information will be aggregated here. You see here aggregation happens. Then see, this is like there is one function. This function is like processing this aggregation. See, one information received here, there is another information received here, there is another information received here. Overall, what happens is definitely summation of the information happens. Now once you get the summation of the information, then you will do the processing. This is it, all the information reaches to the nucleus. Similarly, all the information is summed here. This means that reach it to the nucleus, and the information is being applied by an activation function. This we call it as an activation function, and it will give one particular set of output. Okay, so this is how. So if they naturally in the human brain, we have taken a neuron, the same neuron, we are mathematically modeling its behavior. Okay, this subject is comes under modeling and simulation. Okay, so this is a neuron, and with this is the structure is responsible for all your neural networks. So the basic structure of your deep neural network is this neuron. First, once you understand the neuron, rest of the things will become easier for you. Okay, I hope everyone understood what is neuron. Okay, so again I'm showing in a better picture. These are all the dendrites, and this is the nucleus, this is the axon. Same thing here, inputs are received here. And see, when inputs are received, now what happens? Suppose here 1 2 3 4 5 6, this is the six inputs are received here. So the input travels from here to this red block to the green. No, there is something called connection strength. This is called as connection strength. In connection strength, what happens is, see, this particular channel will have a different weight, and this channel will have a different weight, this channel will have a different weight. There are different weights will be there. Okay, so that different weights, what we are doing is we are showing it, we are showing the different weights in this form. So, and after that, see, suppose let us assume x1 information coming with the weight w1. So how much information will go here? That will be x1 w1. Suppose x2 information going with weight w2. So how much information goes here? X2 w2. Suppose x3 information going with weight w3, then the overall information is x3 w3. So like that the information goes x1 w1, x2 w2, x3 w3, like there's information. The all this information will be aggregated here. Then the activation function is applied. It will be summed and activation function is applied. Then you will get the output. This is how a neuron structure is. This is how we're building the neurons. Okay, so in the neural network now, the basic building structure is neuron. Okay, that neuron, using the neuron will develop a neural network. Using the neural network we will do a deep learning. Okay, so how this step by step we are going to learn today. I hope for everyone, those who even don't know what is a neural network also, they can easily understand what is a neuron and what is all applications, how it is doing. Okay, now I'm telling you, these are all the things I'm going to discuss today. The most basic one is perceptron algorithm. After that, we are going to discuss back propagation algorithm. After that, autoencoder. After that, deep neural network. After that, recurrent neural network. Like this. So these are all the introduction I'm going to give you. Okay. So see, please understand. Now the thing is, I told you already. In the human brain, no, there are various neurons are there, isn't it? So how these neurons are arranged, please understand. I'm again telling you, in the human brain, no, there are so many neurons are there. Okay, indirectly, these when these neurons, no, neurons talk each other. Please understand, neurons talk each other means inside our brain the neurons exchange the information. And finally, see, generally what happens inside our brain, suppose I looked at a dog picture, then one thought generates, isn't it? So that thought, by neurons interaction, the thought is being generated. And with your knowledge, that means every day in every action your neurons in your brain getting trained. Okay, so so basically, if you want to design a neural network similar to human brain, okay, actually how God has given that learning, no one knows. Okay, you understand? So how it happens inside the human brain, how the computation is happening, that is no one knows. Hence scientists have come up with various algorithms. Okay, initially scientists thought the modeling can be done the same way how a human being is thinking, able to discuss the information and all these things. So to simulate that one, first they simulated the neuron, then they want to understand how the learning happening. First they designed one algorithm called, scientists have designed, there is an algorithm called perceptron. Most important is, what is a perceptron algorithm? This is a basic neural network algorithm. Okay, after perceptron we are going to learn back propagation. Okay, so what is a perceptron algorithm? If you look at here, see there is a, see there is a input data, you can see here x1 x2, and there is a target. See, first what I will do, I'm going to discuss with you every derivation and everything. Okay, but the thing is, I'm going to show you with an example also, so that it will be much more clearer for you. Okay, um, now see here, I explained you there is a neural network. Suppose, see first, see there is one algorithm called perceptron algorithm. Okay, so uh, whenever, see there are various algorithms are there, you can see here perceptron, backpropagation, autoencoder, deep neural network, like this. So these are all algorithms, no? Whenever you study a new algorithm, suppose perceptron, suppose backpropagation, one question you should always remember is, one question you should ask is, what is the architecture of the neural network? I already told you, nobody knows how it is happening inside our brain. So scientists have come up with various architectures. So what is the architecture for your perceptron algorithm? That's what we are going to see now. So if you look at this x1 and x2, see, you see here x1 x2, see suppose there is a problem like this. Suppose you have taken a r problem, x1 x2, so 0 0 output. In our problem what happens, 0 0 output is 0, 0 comma 1 output is 1, and 1 comma 0 is 1, 1 comma 1 is 1, isn't it? So one of them true is the true. If both are false, then it is false. That is what is your r, correct? No. So if my neural network, so what I have done now, you see here in this network, when I give x1 x2 as input, I should get target as the output. That means the moment I give 0 comma 1 as input, I should get answer as 1, like this. If I can design my neural network like this, that means the neural network is learned to perform our problem, isn't it? It has understood the data, isn't it? So how do we do that? That is what is the question. So so initially how do we, the main thing is, initially how do we design the artificial neural network? That is what, in perceptron there is a separate architecture style is there. The architecture style is, the number of input neurons, please understand, you see here, number of input neurons are equal to number of features of the data set. Now you see, this is your data set. In this data set you can see here x1 x2 is there. Now these two are called features of the features. Okay, now this is called target is there. Now that is called target. These two are features and this is called target. Now x1 x2 are features and x1 x2 will be given, then you are going to detect the target. Okay, suppose if I give 0 comma 0, okay, then what happens, 0 times this is w1 weight, this is the connection strength is w1 from neuron 1 to the output neuron. And you can see here connection strength is w2 from neuron 2 to, this is called output neuron. Please understand, these two neurons are there now, they are called input neurons. Okay, those two are, each one is for the feature of our problem, like that it is there. Okay, now you can see here there is a output neuron. Now when I provide 0 comma 0 as input, then what happens is, then you will get the output as how much. Now suppose instead of 0 0, suppose I give x1 x2, then how the output is computed? It is computed as x1 times 0.1 plus x2 times 0.3. Please understand, I hope everyone understood this. We compute this as x1 times 0.1 and x2 times 0.3. So that is what is the final output. Okay, because the connection strength is 0.1, 0.1 times x1 information only reaches here, 0.3 times x2 information only reaches here, isn't it? So the main thing is, now what are my weights? Suppose here 0.1 0.3 is there. Now you tell me, suppose I give input 0 0, what will be the output? Suppose I give 0 comma 0, the output will be uh, here out, the output will be 0 into 0.1 plus 0 into 0.1. How much it is? The output is 0. Okay, so in that case, suppose if you take 0 comma 1 as input, then what happens? See, in 0 0 case, you are getting 0 as output. It is exactly matching with the target. Suppose if I give 0 comma 1 as input, then what happens? 0 into 0.1 plus 1 into 0.3. Finally it is how much? 0.3. But 0.3 is less than, see, you can see here 0.3. But how much you should get? Actually 1. But how much you are getting? 0.3. That means there exists a error. I hope everyone understood this. Suppose you see the next one, 1 comma 0. If you keep here, so 1 into 0.1 plus 0 into 0.3 are getting 0.1, isn't it? But you should get answer as 1. But you are getting 0.1. Hello?
Yes, sir.
Somebody is speaking. No problem. Okay, madam. Sure.
Yes,
Am I audible, madam?
yes, sir. Yes, sir. You are audible, sir.
Okay, madam. Sure, no problem. Madam, any students are there in this discussion here in this FDP?
Yes, sir. Yes, sir. Students are
You,
there. Also,
you,
MTech students are there.
can you tell one MTech student, active MTech student, madam?
Let's see. I have to check who is there only.
MTech students, anyone say yes, available?
Maybe I have to check, sir.
Okay, madam. Because when I am asking them na questions, they will easily answer.
Yes, yes.
Then it will be interactive. So that
Yes,
is
sir.
the reason. Some one or two MTech students you can tell them so that
Yes,
they will be active. Yes, madam. Sure.
yes, sir.
Okay. So when I give 1 comma 0 as input, then I am going to get uh, 1. But I am getting here, you can see here 0.1 as the output. Okay. When I give 1 comma 1 as input, I am going to get 0.4. Okay. So this is how this R problem is there. Okay. Now what is epoch 1? What is epoch 1? Now you see here, see first, see there are here is one important thing. What we understood is, we constructed the neural network. We have given some initially random weights, but this neural network is not actually, uh, see, this neural network is actually not suitable. Okay. Because it is not giving you the proper targets whatever you want. So how do you get the proper targets? That is the question. Okay. So to get the proper targets now, you need to train this neural network. Okay. You need to train the neural network as per the input. Now neural network has to experience the training data. Okay. How it will experience the train data? It will update the weights. Okay. So that neural network updation of the weights is there. No, for that there is one formula. See how the formula has come, I am definitely going to discuss with you the proof. Okay. But right now I will show you the formula, because once you understand the example, the proof of that formula becomes easier for you. Okay. So I'm just going to tell you the mm, a, how the weight updations are being happen. Okay. Sorry, any MTech students? There are no MTech students right now. Rajeshri.
Rasri is there.
Yes, 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 very good. Okay. Rajeshri, you are listening perceptron algorithm. You cannot speak. Hello. Okay, you can unmute your voice and you can speak also. You are not able to unmute. I can't unmute yours. Okay, okay, you don't have this one. Okay, no problem. Okay, I will be asking questions, you tell me. Okay. uh, See here. Okay. See, you see here, delta. See, one important point I will tell you. See, this is the input layer, right? Input layer, there are two neurons are there. One is called x1, second is x2. Why we kept two neurons is the first question. Please understand why we kept the two neurons, because in your data set there are two features are there. You see, when I give x1 comma x2 as input, I want target. So that is the reason there are two input neurons are there. That is the first question. Hope you answered that, hope you understand that. Now the next one is, see, anyhow we just verified this network is not giving proper answer. So I am giving here, see, there is a input neuron, this is output neuron, this is the first input neuron. Suppose I will call the index in the first layer as I. Okay, index for the output layer I will call it as J. Okay, then this is called Wij. Correct now, I to J, it is called Wij. Okay, so I is equal to 1 means, so what happens, I is equal to 1 means first neuron. So basically I'm taking W11. What is W11? Is 0.1. What is W21? What is W21? 21 is the 0.3. Okay, so W11, this is W21, that is what they are calling it as Wij. The ith neuron means ith input neuron, it will go to jth output neuron. So in this problem there is only one output neuron. Generally there can be more than one output neuron also. Okay, so how to update the weights, that is how to change the weights, they have given one formula. Can you see here? Delta Wij is equal to eta xi delta j, like this. Okay, what is xi is this one, x1 or x2. I, what is j? J is always 1 because there is only one output neuron for this problem. Okay, I hope this formula is clear. Now we are going to solve a problem. Okay, so we will solve the problem, how it will is going to happen. So Rajeshri, you can't get mic, is there is a problem, there is no other student available? Okay, no problem. So so you see here, when you want to update the weights, when you want to update the weights, how you have to do is, you need to consider like this. See, please understand, there is x1 x2, I have taken x1 x2, then there is w11 is 0.1 and w21 is 0.3. Okay, then see, this is what initially we have taken. You can take any other random values also, no problem. So we have taken with 0.1 0.3. Then first what we have to do is, we have to do the computed. So when the information reaches here, what happens, when the information reaches here, what happens, 0 into 0.1 plus 0 into 0.3, it is like x1 w11 plus x2 into w21, like that it happens. That is actually 0. Okay, so computed is 0. But the most important thing is, whenever you do computation, see, can you see the neural network I have shown you in previous? See, when you see the neural network, there is a summation also, there is a function also. Can you see here, f is their function. So all the information aggregation happens, and also function also being applied. Okay, so that function will apply. Okay, now you see computed is 0, that's okay. But the computed na, when you are computed, if you want means, you need to apply a function also. What we do is, we'll keep a threshold function. Okay, that function we call it as a transfer function or activation function. That function we'll keep it as a threshold function, that is 0.5. Okay, if threshold function, please understand, threshold function is 0.5, that means the output is less than 0.5, it is 0. If it is greater than 0.5, the output automatically becomes 1. So your computed value is 0 because you are getting 0 which is less than 0.5. Hope it is understood. Rajeshri, hope you understand that. Okay, so target already given here, the output as target is 0. Okay, in the given problem target is given. Then what is target minus computed? Target minus computed is um, target minus computed is called delta. Okay, that is called error. Okay, so 0 minus 0 is 0. Okay, what is delta w11? As for the formula, delta w11 is eta x1 delta 1. Okay, what is eta? Eta is 0.2. Assume that right now, you assume eta is some constant. I will going to explain you later how the what is the meaning of eta. Okay, so once we solve this problem, I'm going to go to the theoretical details. Okay, suppose this is 0.2, then how much it is? Suppose you want delta 1 1, it becomes like 0.2 into what is x1. X1 is 0 into what is delta 1. Delta 1 is this target minus computed, that is 0. So 0 into 0, it becomes 0. So delta w11 is 0. Delta w21 becomes eta x2 delta 1. What is x2? X2 is 0 and delta 1 is again 0. The total you are going to get delta w21 is also 0. Okay, so delta w11 is also 0 and the delta w21 is also becoming 0. Okay, uh, so when we go to, now we will go to the second pattern. So that is 0 comma 1, and already given weights are there. Now you see here there is no weight change. After I sent the first pattern, there is no weight change. Then the weight changes is happening, that is 0 0.1, 0 0.3. Okay, when I do now again I will follow the same procedure, x1 into w1 plus x2 into w2. Then what is the computed value? Computed value I'm getting it as 0.3, because 0 into 0.1 plus 1 into 0.3, that is 0.3. But I should not forget that there is, I should compare with threshold. So when I compare with threshold, 0.3 is less than 0.5, so I'm getting the answer as 0. So I kept a computed value as 0, but already in the given problem target is 1, so I'm getting 1 minus 0, that is actually 1. Okay, what is delta w11? Delta w11 is eta xi. Xi is actually 0, eta xi delta j, that is actually 0. So delta w11 is actually 0. What is delta w21? Delta w21, if you say no, what is delta w21 is eta is 0.2. Okay, 2 x2 is 1. So you see, 0.2 into 1 into delta is already 1 here, so that is why delta w21 is 0.2. Okay, hope Rajesh you understood. Okay, so this is how this is how the value has come. See here, previous values, there are no updations, but when it comes here there is updation. Why there is an updation came? Because there is a error. Let us assume there is no error, then there is no need to update. No, that is why 0 0 coming. If there is an error, definitely you need to update something. Okay, so similarly you taken 1 comma 0 pattern, then there is 0.1 and 0.5. Then what happens? Then this is 0.1 and this is 0.5. And so because why it is 0.5? Because previous weight it is 0.3, but delta change it is telling 0.2, 0 comma 0.2. This vector you need to add here, then it is becoming like 0.5. So 0.1, 0.5, now you are getting computed as 0, then target becomes 1. Okay, so this is how. So target is already given here, it as a 1. You see here for the third pattern. So because the target is 1, and definitely there is a error change, there is a change of weight. So change of weight is with respect to the input. You see here, with respect to this input is 0, that's why there is no error component, there is no weight changing component. Because there is something in the input, we are going to change the weight here. Now delta w11, as per the formula, eta xi delta j. What is eta? This is 0.2 into what is x1? X1 is 1. X1 is 1. And what is delta? Delta is actually target minus computer. Target minus computer is 1 minus 0, that is 1. So you are getting here 0.2, 0 is 0. Okay, so 1 comma 1. So input is 1 comma 1. Now you can see here there is you can see here, because there is a weight for, there is a change for weight, then totally it is becoming like 0.3 and 0.5 and computed. Say I request everyone to take your notebook, open the notebook. If you are not if you are not if you don't have fundamentals of artificial neural networks, you open the notebook and solve. All mtech students, I'm telling you, you open the notebook and solve the problems. Okay, it is good for you. You will easily understand further concepts. Okay, because all other concepts depends upon these concepts. Okay, now you see here, you have taken computed as 1, target as 1. So in this case, target minus computed is 0. See why the here most important, see why computed as 1? Because it will be like 1 into 0.3 plus 1 into 0.5, the totally it is 0.8. 0.8 is greater than 0.5. Because it's greater than 0.5, the answer is 1. Okay, the answer is 1, so the target is already 1. That becomes target minus computed. So target minus computed is becomes 0. So once delta is 0, delta w11 is 0, delta w21 is also becoming 0. So this is, see, once you started with 0.1, 0.3 weights, okay, you started with 0.1, 0.3 weights, but these weights are being updated, and you are so there are so the weights are being updated such a way that finally there is no error. Okay, so how do we reach to such a state that it is error free? Now you can see here, when you look at this second pattern, you there is an error one, and second, third one, two, three, third pattern also there is an error, but fourth pattern there is no error. Okay, so finally overall, if you see, if you sum all this, there is still error is there. Okay, so how do you make it error free? That is the question. Okay, so to make it error free, you can see, this is called one epoch. That means once you sent all the input patterns. So if you send all the input patterns again, that means what? If you send once, you started with point 1, point 3, you reach it to point 3, point 5, isn't it? Then you will start with point 3, point 5, where you are going to reach. Now that is what. So next epoch 2, you will start with point 3, point 5, that is like this, point 3, point 5, then you will reach to point 3 points. Now see here, 0 comma 0, if you give input, this is called epoch 2. That means again the same procedure we will follow, same procedure, only thing is weights will start with point 3, point 5. Then you see here, if when you do the same procedure, I request the mtech students, please follow the same procedure repeatedly. Okay, then what happens is, you are going to get a error. You are going to now you see here, I've taken 0 point, see it previously it started with ending with 0.3 join 0.5, so I started with 0.3, 0.5. So again applied the same procedure, then I got again zero point 0.5, zero point 0.7. Can you see here? So again next epoch, this is called epoch 3. Epoch 3 means again I will run the for loop for all the patterns. So I started with 0.3, point 3, 0.7, again run the same procedure, then I ended with 0.7, 0.7. That means what? In my network, no, again for final network, you see all delta values are zeros. So the moment I reach to epoch 4, I got all the delta values are zeros. Okay, so this means this network has learnt it. That means if I keep 0.7, 0.7 as weights, then I will get 0 as the error. Now you see, suppose let us keep here 0.7 and here you keep 0.7, then you run the input 0, 0. What will happen? Anyhow it is 0. If I give 0 comma 1, the answer is how much? 0.7. 0.7 is greater than threshold, so the answer is 1. Okay, suppose you give 1 comma 0, the answer is again zero point 0.7, that is greater than threshold, that is 1. 1 comma 1 if I give, that is also 1. So that means I'm getting all the answers are correct. Okay, so that means there is no error. So we have designed one mission. This is actually neural mission. One mission we have designed. That mission is able to predict, able to detect the input pattern such that it accurately calculates the output is matching with the target. Okay, so this is what is called R problem solved using perceptron algorithm. In perceptron algorithm, weights are being changed means the network is getting maturity. That means the network is experiencing something. Okay, so it is live and it is experiencing and it is behaving as per the target. That is what is happening. Okay, so now the question is, uh, so this is how we solve the perceptron problem. Okay, in the perceptron algorithm, basically we are using this particular formula. Now the question is how this formula is helping us to update the weights. Okay, just I'm giving you 2 minutes break. I will just drink water and I will come back to you. Okay, just 2 minutes. Okay, we'll start. So the question is now, how do you update the weights? That is the question. Now to update the weights, there is a proof we have to go through. Okay, so you see here there is an error. There is an error. Error is target minus computed whole square. Okay, what is the target? You can see here in our given problem. See, these are the targets. Okay, see, basically this R problem I'm calling now, the R problem now, these are actually features. Okay, these are actually features. Now this is what this is a target. Okay, in this is actually one data set. In this data set, these are called features and this is called target. These are, some people call them as labels also. Okay, see, these rows are there, no, these are called records. Okay, so total how many records are there? Answer is 1 2 3 4. There are four records are there. So how many features are there? The answer is there are two features are there. How many labels are there? You see, label means you should count, you should count only one. So 0 or 1, that means two labels are there. Okay, two labels are there means there is, this is a two class problem. Okay, so this is basically smaller version of a data set. This is a small sample data set to explain you its algorithm. I have shown you a numerical example like that it has happened. Okay, now let me explain you the proof. Okay, now basically what we want in the problem I already explained you. There is a data. Okay, in this data, yeah, Rajesh, you are having any doubt? Anyone is having any doubt? Someone raise a hand. Okay, okay, no problem. Okay, now you see here there is a proof here. Now there is an error function. How the error function is defined? We know, right? Target minus computed whole square. Target is already there. That is tj minus computed. What is computed? Computed we know xi wij. What is wij? Wij means weight from input to the uh, weight from input to the output layer. Okay, that is ij. So this is what is our wj. So this is summation xi wij, because you are starting with xi, it becomes xi wij. Okay, so it is like dou e by dou wij. If you want dou e by dou wij, it becomes like 2 times 2 2 gets cancelled, tj minus oj, target minus output, into xj into xi, because wij becomes 1 then becomes xi. Okay, so target minus output into xi, this is what by wij. See, please always remember one thing. The moment, see, here many people gets confused. The moment you get the first order derivatives, na, first order derivatives, the moment you get, na, you came to the end of the problem. That means you solved the problem. Why? Because in the mathematics, no, there is one formula called steepest descent formula. Okay, there is something called steepest descent formula. It says that, see, negative, see, there is a, see, there is a negative of the gradient, na. If there is a, it is like that. It says that steepest descent rule, change in weights. So you have to always change your weights in proportional to the negative of the gradient. Negative of the gradient means delta wij is proportional to minus dou e by dou wij. This is what should happen. Change in weights is always proportional to negative of the gradient. Okay, so delta wij is equal to k times what happens, dou e by dou wij. What is dou e by dou wij? You already found out on top. That is target minus output into xi. If you substitute that one here, it becomes like tj minus oj into xi. Okay, if you call this k as eta, the eta, you call the target minus output as delta. Okay, Please understand, again I'm telling, if you put in place of k as eta, constant as eta, and target minus output j is call it as delta j, so that is like eta xi delta j, that is delta double. So this is what is this formula, this is how it is derived. I hope everyone understood the proof. Rajeshri, understood? Yes, very good, very good. So so the thing is, so basically what I want to tell you is, the moment you found out the gradient dou e by dou w ij, it is like, once you get the gradient, then you get the delta w. Delta w and gradient, the relationship is, gradient is always proportional change in weights, that updation, that is called forward operator and differentiation, the relationship. Okay, the forward operator delta is like w of t plus 1 minus w of t. That forward operator is same as k times target minus output into xi. This is what is your perceptron algorithm. So what we have done is, we have utilized this formula. Using this formula, we have taken a neural network and we updated the weights. Okay, then once we updated the weights, finally we reached to the conclusion that it is actually working. See, it is not simply a principle, a theory like that, but the theory we kept in the terms of a formula, and the formula is actually giving you the algorithm to train. Okay, this is how exactly it is happening, right? So what we will do now is, you see here, this eta is there, no, this is called, can you see here what is eta? This, when I remove this proportionality constant, now you are getting eta. So this eta is just like a constant, and it is like a step length. Eta is like a step length. Okay, step length means how much. So let us assume that you put eta as 100. That means what? For the old weight, you have to multiply with, you have to add this. That is the meaning, na? That's what we have done. See, old weight is 0.3. For that, I change of weight is 0.2. So I am adding. That means step length is how much? See, zero point 0.5 minus zero point 0.3, how much? Zero point 0.2. That means zero point 0.2 distance ahead I went from 0.3. Correct, na? Now the question is, this delta w is there, na, this eta is there, na, how much eta it should be? So if you take a big eta, that means you may go out of the bounds, right, somewhere. So that should not happen, correct, na? So that is the reason we always take eta between 0 and 1. Okay, if you take the eta between 0 and 1, it will give the step length in a appropriate fashion. You cannot give eta as 100, 200 like that, because it goes beyond the limits. Okay, so now we have taken this formula and nicely we solved an example, and we got the answer, which is all the time, which all the deltas are zeros for 0.1. So now the similar question I'm asking. See, earlier I shown you one data set, that is our problem. There are two columns were there. That is the reason you have taken two input neurons. Okay, now I am asking you, how many how many input neurons are required for this following data? Okay, suppose x1, x2, x3 and target are there. X1 is 0, x2 is 0, x3 is 0.1. The target is 0. Now you see here that earlier problem there was a target which is either 1 or 0, correct? No, now the present problem, you see here, x1, x2, x3, there are features which are two actually. See, 0 comma 1, there is a target which is actually 0 comma 1, 1 comma 0, 0 0 and 1 0. So x1, x2, x3 input I will give you. X1, x2, x3, suppose x1 is 0, x2 is 0, x3 is 0.1. If I give the input, then target is how much? Target, there are two neurons are there. Okay, target, there are two neurons which is 0 comma 1. Okay, why we have taken two neurons? Because in the target, in the given problem itself, they want two output, not one output. So we have taken two neurons. Now input is taken randomly, right? This is, initially randomly have been taken, like 0.5, 0.3, 0.7, 0.6, to apply the present algorithm. Now in this situation, the architecture how it looks like is, that's what shown here, isn't it? This is how the algorithm architecture looks like. Okay, So because there are three features are there, x1, x2, x3, those three features are taken, and there are two output neurons have been taken. This then you apply the same weight exchange formula, weight updation formula, and run the algorithm. Okay, then you are going to get the answer definitely. Okay, so this is how you need to apply perceptron algorithm. Now you see there is something called see, this is what we already discussed, right? So now there is something called, you see, there is one concept called here that concept I'm explaining you, most important concept. See, first what happened is people have solved this problem using perceptron, okay, but the scientists have observed that the same algorithm, the perceptron algorithm, it is not going for convergence. It is not giving you convergence. What is the meaning of convergence? Convergence means weight should be updated such a way that this delta should be completely zero. If this delta, suppose let us assume that you run the code and it is going to the infinite loop, okay, that means what? It is not stopping, it is continuously going into the loops. So such kind of cases, such kind of cases, what we do is, we are, this perceptron algorithm, it won't work for, there are some certain types of data, that is, if the data is not linearly separable. If the data is linearly separable na, definitely it is going to work. If the data is not linearly separable, svm algorithm doesn't work. Okay, this is what is this is what is the most important concept. Okay, now, what is the meaning of linearly separable and non-linearly separable? Here you see there is one geometrical picture I'm giving you. Here you see. First we discussed about R problem. Okay. In the first we discussed about R problem. In the R problem, what was the concept? 0 0 is 0. Remaining cases the value is 1. Okay. In the end problem, what happens? 1 1 is 1, remaining case all are 0. Okay. Similarly, XR problem, 1 1 is 0 or 0 comma 0 is also 0. Correct. Nah? So both are there now. So how it is, how this is going to happen? How this is, so if you see here, if you look at the end problem, if we are doing to see everything to understand, now we should go see in mathematics. Now there are two things are there. One is called this algebra, second is called this geometrical meaning. Okay, if any want to think anything you want to prove now, there are two ways. Either you want to take the algebraical way, either you can take the geometrical way. Okay, right now what we are discussing is in a geometrical fashion. Okay, geometrical fashion means you need to draw the data set to understand the properties of the data set. Suppose you have taken the data set is having weights. Okay, 1 comma 1, you can see here there are there is a green dot here, green dot here, green dot here, which is actually represents, you can see in the given problem there is 0 comma 0, there is 0 comma 1, 1 comma 0, 1 comma, 0 comma 0 is there na. This is what is 0 comma 0, this is 0 comma 1, 1 comma 0, this we call it as green bar. Okay, so and 1 comma 1, the output is 1 na, that we are showing it as this red color. Okay, now here there is so you see here in our problem what happens. Our problem na, 0 0 is 0, remaining cases it is 1 na. So we are showing here this is as a 1 1 1 like this. Here we will show, now this is our problem. Now in end problem, can you observe one important thing, that one you can see here, in the end problem na, you can separate these green dots and the red dots using a line. Okay, this is called linearly separable. Now you see r points na and blue points you can separate by a line. Now you can see you cannot separate green points and red points, okay, with one line. You see the XR. So that is why in the literature many times they say XR problem cannot be solved, okay, because it's not linearly separable, okay. XR problem cannot be separable, it is not linearly separable. So in that case, what happens when there is a problem which is not, so if it is a linearly separable case na, in that case easily you can apply perceptron algorithm, right? So why because now can you see here, most important thing, you are taking x1 and x2, you are multiplying with w1 w2, what is the output you are getting? Output is x1 w1 plus x2 w2. So exactly the output is like this. Can you see here, x1 w1 plus x2 w2 like this? So x1 w1 plus x2 w2, if the output is something greater than, then you are getting the output is either 1 or 0. Means correct na, either 1 or 0 means exactly this represents, actually it is like ax plus by plus c. What ax plus by plus c represents? A line equation. So this is a line actually. So one side all the points giving 1, one side all points giving 0. That is why that classification is happening, either giving output as 0 or 1. So there is a line which is separating both these points, then that is the reason it is called as linearly separable. It is called linearly separable, okay. Perceptron which is linearly separable. Now perceptron algorithm works for this perfectly and problem. Perceptron works for R problem, but perceptron doesn't work for XR problem. Now what to do with the perceptron algorithm? What is perceptron? We will see. Perceptron is this one. We have taken input layer and output layer, and this does not work. In that case, what to do? What to do is, in such a situation, you need to introduce one more layer, that is called as hidden layer. You can see here, this is an input layer, there are green color dots, then there is an output layer blue color, then we introduce one more layer called hidden layer. This is what is the hidden layer, okay. With this hidden layer, then you will give the inputs, then there is output at the hidden layer, there is output at the hidden layer. So again outputs will be given. So this is how you are going to you are going to form a multi-layer perceptron, okay. We can easily form a multi-layer perceptron. Why? Now the question is, this type of architecture is there, no? Earlier architecture is there, no? That is called perceptron architecture. But this kind, when you introduce a hidden layer in between, such an architecture is called multi-layered architecture. Why it is called multi-layered perceptron architecture? Why? Because if you look at here, in the same architecture, you take two neurons and take one neuron from hidden. So this triangle is there na. You see here, there is a line goes, it comes like this triangle type. So such a thing is called, now you see here, it starts here and it goes there and it will come here. It will start here, it will come here, it will start, it will go, it will start. So it is like that key, it is having, um, so basically it is having a particular architecture, okay. That particular architecture, um, so it is basically, it's basically having a separate, it is having basically having a separate architecture. So so many perceptrons are mixed together. Can you see here, these three are one perceptron, these three forms one perceptron. Now see here, this blue red and blue and red, so this is one perceptron. So this is how so many perceptrons are there. So this is called as multi-layered perceptron, okay. This multi-layered perceptron is there, no? Now earlier we said perceptron algorithm, then we have done one proof, because one weight updation equation is there, isn't it? So we have used the steepest descent principle. Now in multi-layer perceptron also we are going to use steepest descent formula, okay. So we are going to use, there is an algorithm called back propagation algorithm. That back propagation algorithm, how do we train using back propagation algorithm? That is the most important thing, okay. I hope everyone understood this. Before going to the back propagation algorithm, there is one concept called, please understand, there is one concept called bias, okay. We should know what is bias, okay. See bias, what is the meaning of bias in a neural network, okay. Bias in a neural network means, suppose if you have a data x1 x2 and there is target, you can see here, there is x1, there is x2, There is x1, there is x2, and there is a target. This is 0 0 output is 0 0 comma 1 output is 1 1 comma 0 output is 1 1 1 is output is 1, correct now. Now there is something called bias, that is 1 1 1 1. Now you see here 0 0, the target is 0, right? See what happens is with this na 0 0 you are getting 0 0 1 you are getting 1 1 comma 0 you are getting 1 comma getting 1 na. Now this is target is there na. Now here na you may get a decision layer. The decision layer is like this, correct na. This is actually L1. Okay, now this L1 you can, but the decision layer, which is the line, is not see I told you already here. See here you are having w1 x1 plus w2 x2 kind of thing. Now how to get some other constant? It is like ax plus by only. I want to get ax plus by plus c. How will I get? I will put c into 1. That means I what I will do is in the given data I will put one more feature, all 1111 kind of thing. If I put all 1111, that means c into 1, then what happens is that is called as bias. So what is a bias? Whose input is always 1. Why we are using bias? Because that biasing, there is that decision surface is there, the decision line is there na. That decision line shifts from one place to the other place. That is this line. Okay, that decision line, because it is shifting from one place to the other place, it won't pass through any the data point, any of the data point. It is actually a fine transformation. It is little bit lifted from the origin like this. Okay, so from L1 to L2, if you want to get, you can use bias. Bias is very simple, anytime you can use. Only thing is the meaning of bias is you need to always have an input neuron which is always 1. Okay, this is how it is. So now bias is in general, it is not part of training, it is part of architecture. Hope you understood that. Now the thing is, we are going to study about this back propagation algorithm. So for again we will follow the same procedure. The procedure is same. The procedure is how we will apply the back propagation algorithm. Okay. See why we call the algorithm name is back propagation is, what we will do is, first we will give the input neurons here, then it will go to the hidden layer. This is input layer, then you will get to the hidden layer, then you are going to get the output layer, then you will get the output, isn't it? From the output now again you can compute the hidden layer. From the output you can again compute the hidden layer. From the hidden layer now you will come back to the input layer, isn't it? So this is how it is happening: input to hidden and hidden to output, and output to the hidden and hidden to the input. So because it is our weight updation is happening from the behind nearest. So if I want to update the weights of this again, it will, we can update the weights from here to here, isn't it? So if we want to do like that, that is the reason it is called as back propagation algorithm. You are updating the weights in a backward direction. Okay, now to understand that everything, first we will solve an example. First, after solving example, we will understand the theoretical details, how it is actually working. Okay, what is happening inside this. So earlier, if you remember, to solve the perceptron algorithm, what we have done is, I have taken a sample data set. That sample data set, I have used a sample data set. That particular sample data, suppose you see here sample data set zero point 0.4 minus zero point 0.7 and the target is 0.1. Okay, zero point 0.4 minus zero point 0.7, target is 0.1. Now what is the output you are going to get? Now from this 0.4 minus zero point 0.7, now suppose if you are using, there is a neural network. Okay, suppose this is a neural network. Now the input is like zero point 0.4 minus zero point 0.7. Suppose this is zero point 0.4, this is minus zero point 0.7, and this is a multi-layer perceptron. Okay, and the input is 0.4 minus 0.7. So input to hidden, this is called hidden. So input to hidden, I have taken a, what I have taken, input to hidden we have taken some random weights. This is 0 0.1, 0 0.2, 0 0.2, 0 0.4, like that. And hidden to the output to the hidden, we have taken uh, here, there are random weights 0.2, 0.3. Okay, so this is what is happening. So now how we will update? So suppose you take 0 0.4, suppose we have taken 0 0.4 and 0. Suppose we have taken 0.4 minus 0.7, then what is the output you are getting here? 0.4 into zero point 0.1 and minus zero point 0.7 into zero point 0.2. Then you are getting the output as minus zero point 0.1. Now you see here 0.4 into zero point 0.2 minus zero point 0.4 into minus zero point 0.7 into zero point 0.4. What output you are getting? Minus 0.2. Okay, so it is better some MTech student will do the computation. Rajeshri, are you doing the computations? Hmm? Okay, you do the computation and tell me what is the answer. See, point 0.4, see, point 0.4 and minus zero point 0.7 are there now. 0.4 into 0.1 minus zero point 0.7 into 0.2. What is the answer? Just one computation you do, that is enough. That means from input layer to hidden, hidden to output you do, that is sufficient. How to do, I'm telling. Take a calculator and find out the value listed there are proper or not. The moment you get the answer, you tell me. See, 0 0.4 into, see, minus 0 0.7 into 0.2 na, it is given there 0 0.2, you see here. So it is like 0 0.4 into 0 0.1 minus 0 0.7 into 0 0.2. What is the answer? You should get minus 0.7. Are you getting? Minus 0.1, are you getting? At the hidden neuron, at the first hidden neuron, you should get minus 0.1. Okay, very good. Now what you do is, similarly you calculate the at the second similarly you calculate at the second hidden neuron. 0.4 into 0.2 minus 0.7 into 0.4. What is the answer? Second one, similarly, 0.4 into 0.2 minus 0.7 into 0.4. Find out what is the answer. Zero. Why? 0.4 into 0.2, please understand, 0.4 into 0.2 minus 0.7 into 0.4, you should get minus 0.2. Are you getting minus 0.2 or not? Okay, very good, got it now. You got here minus 0.2 now. You see here, you got here minus 0.2. This value you got, correct now. Similarly this value also you got. Okay, see, the most important thing here is, so the most important thing here is, you are getting these values. Now for these values, for these minus 0.1 or 0.2, how do you apply that? See, in earlier now, when you are doing perceptron, what you have done? When you are doing perceptron, you are actually, once you get the computed value, you are comparing with the threshold or not? You are comparing with the threshold, isn't it? Now what we do is, because this is back propagation algorithm, now in back propagation algorithm, in see, in this is perceptron algorithm, we use something called threshold. Means if some value is greater than 0.5, you use 1, otherwise 0. If something is greater than 0, you can use 1, otherwise 0. So there is something called step function. You can use functions which are called step functions of type. You can use, then they are giving you the proper answer. Now, but reverse is, now you see here the data, you see, is it not a continuous data? Can you see here 0 0.4 minus 0 0.7, 0 0.1? But earlier data 0 1 kind of thing, there discrete was working. Discrete is like this kind of activation function, but right now you need a continuous activation function. How do you get a continuous activation function? That is 1 divided by 1 plus e power minus x. Okay, this is called a continuous activation function. Okay, this is in this continuous activation function we are having like continuous and or differentiable and bounded so what we are doing is this continuous activation function, this is called sigmoid function 1 by 1 plus e power minus x. This also gives the value 0 comma 1. So what we are doing is here we are going to change. Now you see here 1 by 1 plus e power minus x now you substitute. Now you got this value minus 0.1. You send it through 1 by 1 plus e power minus x and tell me what is the answer. What is the answer for that? If you send it through 1 by 1 plus e power minus x, what is the answer? Are you getting 0.47 or not? Find out. Send it through 1 by 1 plus e power minus x. That means you need to find out 1 by 1 plus e power 0.1. Then you should get 0.47. Okay, you got. Now similarly you should send through one second value. This minus 0.2 you got minus 0.2 this value you send it through the activation. Are you getting O2 or not? Find out. See here x1 x2 came in the hidden. Now you got O1 you got already. Now O2 are you getting 0.45 after sending to 1 by 1 plus e power minus x? That you find out. Got it? That means 1 by 1 plus e power 0.2. Very good. So hope you got. Then what you do is, see 0.47 you got, 0.45 you got. So you send through one input, you are going to generate some other output. Then what we are doing is, see these two inputs are there, 0.47 0.45. These two are the now inputs for the hidden layer. Those two we will give input to the next one. So 0.47 into zero point 0.2 plus 0.45 into 0.3, then total is how much now? 0.47 into 0.2 plus 0.45 into 0.3. Compute and tell me what is the final answer. You should get 0.557. Are you getting 0.557? Are you getting 0.557? So this is 0.557. Are you getting 0.557? Very good, very good. So now what you do is, now because you got this 0.557, so that means what, you started with 0.4 minus 0.7, your output is 0.557, correct? But here what is happening is, you see here how much output you should get actually. Target is how much? 0.1. Okay, so now what is the error now? Zero point 0.1 minus 0.557 is the our error. Okay, so to solve this problem, to solve this problem, you have to do weight updations. Okay, how the weight updations are there is the question now. Okay, so the weight updations, there is a formula, that is this one, that is delta wij. Delta wij is equal to eta xi delta j. You see what we do in like earlier formulas input is there we input neurons, we call it as I. Hidden neurons are there we call it as j. And output neurons are there we call it as r. Okay, so I index, if I say I is equal to 1 means first neuron, if I say I is equal to 2 means second neuron in the input layer, if I say j is equal to 1 means second first neuron in the hidden layer, j is equal to 2 means second neuron in the hidden layer, r is equal to 1 means one neuron in the final layer, like that it is. Okay, so for to change the weights, there is a formula. Suppose first, I already told you, in the back propagation you need to first update the weights in the previous behind layer. So it will be like, what is the answer now? Delta vjr. Delta vjr is what? Eta oj delta r. So it was like delta vjr is equal to eta oj oj means this one. I told you already. O1, O2 means this one. So OJ delta R. Delta R means how do you compute delta R? The formula is OR. Whatever output you are getting, that is OR. OR into 1 minus OR into TR minus OR. What is the output you got? 0.557. That is our OR. Okay. See, here output we call it as OJ. Here outputs we call it as OR. Okay. As per this formula, if you want OR, suppose if you want delta V11, please understand, if you want to see, this is called delta w v delta v11. See, if you want to update v11, you need to find delta v11 to add to this, correct? No? So how do you find that? So to find that, we are actually using this formula. You see here, delta v11 is equal to eta oj delta r, right? Oj or into, so indirectly the value is 0.557 into, it will be like this, 0.557 into, this is 0.557 into 1 minus 0.557 into TR. Already target is given na 0.1, 0.1 minus 0.557. That is our delta R. If you compute that calculation, you are going to get delta as minus 0.112. This you will get. If you want to do it, you can do it right now. It is like 0.557 into 1 minus 0.557 into 0.1 minus 0.557. If you do that, you are going to get this. Okay. Then similarly you can, similarly you can see, then once you get this delta, then you can compute this delta vjr eta oj. You already know oj, you already know, right? Then delta r you already know, so you will add, multiply them, you will get that, isn't it? So this is how you will get, see, this is how you get delta r. Okay. So similarly there is something called, see, how do you update the weights between input and hidden? Because this is I, this is j, we call it as delta wij. What is the formula for that? You can see here, delta wij is equal to eta xi delta j. But xi you already know, eta you already know, you can choose one eta if you want, eta is a constant. Then what is delta j is the question. Delta j completely depends upon oj into 1 minus oj into summation vjr delta r. So it is like oj into 0.47 into 1 minus 47.147 into summation vjr delta, like that the formula comes. So this is how you will update the weights. Okay. So you will again update the weights here, then again take the second pattern and send it here, update the weights at the v, then update the weights at the, again send the third pattern and find out o1 o2 and go to or, update the weights between the output layer, hidden layer, middle layer and final layer, then update the weights at the w. So like that, if we are keep doing now, we are updating the weights now, the neural network gets fully trained, isn't it? So this is how it happens. Okay. Now, see how these calculations are happening. I already explained in this slide with a notebook example. Okay, you can go through when you have free time. Okay, but that is the most important thing. Okay, now I would like to explain you one important thing. See, this is how back propagation works. This is why it is called as back propagation. Okay, so in perceptron also there are weight updation equations. In back propagation also, when you introduce a hidden layer, there is a back propagation algorithm. Correct? There is a back propagation um, weight updation equations, correct? Now the most important thing we are going to discuss, that is called as next algorithm we are going to discuss, that is called as autoencoder. That is called as autoencoder. Why autoencoder is most important? That is what, first of all, is it a neural network is the question. See, we all know that neural network is used for what? Neural network is used for the recognition tasks, isn't it? Neural network is used for the classification. Okay. When you give an input, it will classify the 0 or 1, same thing like our problem, for the input pattern it's going to classify the things. Okay. But now what we are doing is we are going to uh, but the one more property, one more behavior of artificial neural network is, it will also it will actually, it is having one more property, that it is also used for dimensionality reduction. So So during the process you learnt perceptron, you learnt back propagation, and you see 70% of neural networks you already learnt. Okay, see everywhere na, see the same back propagation will be there. It will do some other task. What it will do? Okay, that's why back propagation algorithm is the most important algorithm. Okay, now now we are going to discuss an algorithm called autoencoder. This autoencoder is there na. Autoencoder is not used for classification, please understand. It is used for dimensionality reduction. Now let us understand what is the meaning of dimensionality reduction. Okay, now you see here, dimensionality reduction means in the machine learning now there is one concept called curse of dimensionality. What is curse of dimensionality? Now you see here, if there is one dimension, if there is something of one dimension, then what we do, we will subtract. If there is something for one dimension, then we will subtract from, suppose, see please understand why dimensionality is most. Dimensionality means number of features. So in the given data now, if there are more number of features are there, that data is not, it is difficult to work with such kind of data if there is more number of features. Now the question is, if there is more number of data, that is called as more dimension, then there is something, one concept called curse of dimensionality happens. Now the question is why it is a curse. Why it is a curse? Because as the number of features increases, traditional machine learning algorithms, what are the traditional machine learning algorithms, like k nearest neighborhood, like svm, support vector machine, like decision tree, all these algorithms will fail. All these algorithms you cannot simply apply. You need to reduce the dimension and apply. Now the question is why I need to reduce the dimension. I don't want to reduce the dimension. Proceed further to understand its geometrical. I told you, to understand in mathematics anything, there are two possible ways. One is either you go through algebraically or you can go through geometrically. Now I am going to explain you, because it is simple and easy proof, that is how the curse of dimensionality happening through a geometrical description. Now you see here, now suppose there is something called one dimension you have taken. In the one dimension na, suppose if you have 0 to 1 length na, suppose you remove 90% data, how much is remaining? That is 0.1, 10%, correct na? Suppose if you have 2D, two dimension, suppose there is like this. Okay, there is two dimension, suppose there is 0 comma 1 like this. Suppose you remove 90% data again. 90% means what? In the two dimensional, that is 1 minus. Now 90% means how much? 0.9 into 0.9 na, zero point 0.9 square na. Zero point 0.9 square means how much it is? That is actually 0.19. That is actually, so you see here in one dimension, whatever it is remaining space na, remaining space is 10% only. If you go with the same logic na, in two dimension, what is the remaining space? You see this blue color remaining space is 0.19. That is actually 19%. You see here, suppose in three dimension na, I want all these blue colors, then how much it is? 1 minus zero point 0.9 whole cube. What is zero point 0.9 whole cube? That is 0.271. That means remaining space in the edges na is actually 0.27. That means 27%. So as the dimensionality increasing na, that inside space now, inside space is actually reducing outer. So all points are going towards the edges. Okay, when all points are, so if I go to 50 dimension, then it become 1 minus zero point 0.9 for 50, that is 0.994. So 0.994 is the edges places. So when all points are going towards the edges, there are no points in between the boxes, then what happens? So it is difficult to visualize such a picture, and you cannot do clustering, you cannot do classification, all these tasks because those are all algorithms not designed for such kind of data. You understand? When the data is proper, it is aligned with x-axis, y-axis, then we can do it. But all data is going towards the edges, then how will you do? Because all the property of the data sets are going to change now, isn't it? So one room ka edge is close to the next room ka edge, like that it is happening. So there is no center point. Generally what we do in case, suppose you take k-means algorithm, we find the center point. From there we say that which is the another center which is nearby, we are going to see like that. But here what is happening? Here all the points are towards the edges. Now there is no concept of center only, so you cannot apply traditional algorithms. So this is called as curse of dimensionality. Okay, So how to reduce the curse of dimensionality using auto encoders is the question. Now there is something called feature selection, there is something called feature extraction. There are two important concepts are there. Feature selection means, suppose if you have data like this, see, you know that this is a 6 dimension data. So feature selection means I want to select the best features from this, which are exactly, now you see here I would selected x1, x4, x5. I would like to tell you that remaining features are there na, pointed, pointed, you see here, point 0.6, point 0.6, point 0.6, these are all useless features. Useless I mean not useful right now, they may be useful later. Now you see here point for point with the same, they are repeating actually, they are not providing any extra knowledge. Okay, so that is the reason we consider x1, x4 and x5. Similarly feature extraction, what I will do, x1, x2, x3, x4, x5, x6, then I have taken, now this is called as feature selection. I'm collecting the same features, but there is in this way also you reduce the dimension. That means by removing the unnecessary features you are going to get the useful features. Now here feature extraction means, see, feature selection means this one, feature extraction means instead of 6 features na, this means this is like a matrix, no, instead of 6 features I am coming up with some other, please understand, instead of 6 values I am coming up with some other matrix, some other values. Those values are equivalent with these values. Okay, now I want to collect the 3 different values like y1, y2, y3, but those are equivalent with this. Okay, so how we can say that these are all equivalent, this is by applying PCA algorithm. There is something called principal component analysis. You can apply principal component analysis, then you will get, isn't it? So to high, but here the difference is you will copy the exact feature. Now you see here point 1, point 2, point 3, here also point 1, point 2, point 3, but here you see point 1, point 2, point 3, it's different, point 1, point 2, point 1, because x1 is different from y1. Y1 doesn't match with any of these features, it is entirely different. Okay, so this is called as feature extraction. Okay, now your auto encoder is there, now you are going to learn, it will do this kind of thing. That means high dimension to low dimension it will map, isn't it? So how that is happening, suppose if you have input 1 stone x3, x4, x5, now there is z1, z2, z3, and these will be, this input is there now, this input is x1, x2, x3, x4, x5 is mapped to z1, z2, z3. So like that this mapping is happening. Okay, just 2 minutes, I'll drink water. Now, now let me explain you. There is now I have told you there is something called feature extraction. Now, how your auto encoder does this task is the question. Now, suppose you have a data like this: x1, x2, x3, x4, x5, x. There are six features are there. Six features you want to convert into three features. Okay, how do you do that? Because there are six features. Now you take here. Now you see here there are six features. You want to convert into three features, right? You take this input neurons are six. Okay, the same number of input neurons you take here this side also, so that, and you apply the same back, whatever we studied, the back propagation, the weight updation equations, everything. You apply the same weight updation equations. Then what happens is, then you apply the same weight updation equations. Then the same weight updation with the same weight updation equations, so network gets trained. See here, many people have doubts. This is the, now I am going to explain you one concept that is the basis for your recurrent neural network, that is the basis for deep neural network. Now let me show you one important point. This is what many don't understand, but it's the most easier one. Now you see here, when the input now, you see here, when I input I'm giving zero point 0.4 minus zero point 0.7, right? See, you see here, when I'm giving input zero point 0.4 minus zero point 0.7 na, then when I apply sigmoid na, I am generating another, I'm generating another two numbers, that is 0.47 and 0.45. If you see here, correct na, o1 o2. That means if I change the input, I will get different O1, O2. Correct now. So based on the input, O1, O2 are generated. So for every input, for every different input, I'm getting different O1, O2. Let us call this as hidden data. Suppose you collect the data like this, all 0.47, data. If you collect, no, this data is called as hidden data. Correct no. Like hidden neurons, no, hidden neurons produces hidden data. That hidden data is there, no. If you send again backwards, please understand, keep on, then that is going to become a recurrent neural network, that we are going to discuss later. After deep neural network we are going to discuss it, but right now let me explain you that hidden data is there, no. Same thing you can also collect here, please understand. You have taken here, please understand, six input neurons, x1, x2, x3, x4, x5, x6. These six input neurons, you have taken three output neurons. Suppose you take here, there are three output neurons, there are six input neurons, there are three output, three hidden neurons. So for every input now, suppose if you give this input point 0.1, point 0.8, point 0.6, point 0.2, point 0.1, point 0.4, then you are going to get point 0.1, point 0.7, point 0.9. You are going to get three. Suppose if you will generate these three vectors like o1, o2. Suppose if you do point 2, point 1, point 3, point 9, point 4, you are generating point 2, point 6, point 1, 3. Suppose point 3, point 6, point 7, point 2, point 3, point, you are generating point 1, point 2, point 3. So for every input vector, you are going to generate a triple like this. So that's why three neurons were kept in the autoencode. That means what? 6 dimension to it is reducing to 3 dimension. Hope Jayshree, you are understanding all the concepts. You are understanding? Jayshree, you are listening? Okay, very nice. Now what I have to do is, what I am explaining is, uh, so these are the, so these are the various uh, these are the various input neurons, and this is the hidden neurons. So six input neurons are converted into three hidden neurons, right? Those that data, so from the data is so anyhow we told there is a curse of dimensionality. High dimensional data we don't want, so to convert high dimension to low dimension we are using autoencoder. So till that you understand. So now let us go back to the original definition. See what it says now, as per the Wikipedia, there are two types of definitions in the literature. If you see all the research papers, there are two types of definitions exist for the deep neural network mainly. What are the two definitions? The first definition is, you will have a back propagation algorithm, correct now. If you put more than one hidden layer, please understand, if you put more than one hidden layer now, then you are going to get you are going to, actually that is also a deep neural network. If you put more than one hidden layer, Okay, if you put more than one hidden layer, that is a deep neural network. But when what happens in that situation, when you put more than one hidden layer, this entire computation, no, which will be much more complicated, because when you update the weights, you need to send it from the last layer to the hidden layer to the again second hidden layer, second hidden layer to the input layer. So it is much more complicated, and there is a chance that this gradient values in between gets nullified, because already weight change happens in 0.00, so those values becomes nullified. So what to do in that situation? So that in that situation, there is one method called, there is one more definition is given for the deep neural network, that is called as um, there is one more definition for the deep neural network, that is called as stack of autoencoders. That is called as stack of autoencoders. What is stack of autoencoders? Suppose if you have an autoencoder like this, x1, x2, x3, x4, x5. Now you see here, what we will do is, here there is a there is a five dimension to four dimension we will convert, then four dimension to three dimension we will convert. See, please understand, you know, right? If you want to convert six dimension to three dimension, you did this auto encoder. Similarly, now what we'll do, I want to convert five dimension to four dimension. Then I train this using back propagation. Then four dimension to three dimension. I will generate one more auto encoder. So these are called several auto encoders. These are when I group them. Actually, when I group them, what happens? Grouping means after training now, I will get these weights now. I will use these weights here. From here to here now, I will use the same weights here. From here to here, I will use the same. Then what happens is, mm, then here to here I'm using the same way. I will train the weights. Then totally what happens is, now please understand, when I give input here, basically I am training this three layer network only. Basically I'm training this three layer network only. Here also I'm training this. With this final data, I'm training this two layer network on. Finally these weights whatever you updated now, already these are trained weights. Okay, hence training of this. So indirectly you got the trained weights also. See, you got the trained weights from here to here, you got the trained weights from here to here, you got the trained version. So finally you are going to generate a deep neural network. So here also you are having more than one layer, but they are in a structured fashion, and they are trained in a easier fashion. They are trained in a grouped way. That's why these are called as grouped autoencoders. You are training them in a easier fashion. So this is called as, see, stack of autoencoders. This is one autoencoder, this is one autoencoder. See, I'm telling you, suppose this gray color to red, this red orange color is there now, you put w. That means what? Same w after training na comes here. Here this orange to green, suppose you call v, same v comes here. Whatever the data generated now, you train with two neurons with perceptron, same weights comes here. So finally same weight update. So this is kind of model is called deep neural network. This is called stack of autoencoder. So deep neural network is having two versions. One is stack of autoencoder, second is keeping more than one hidden layer. Okay, so this is, hope you understand. Okay. So in this network now, what you basically require, you need numerical numbers. Okay, so if you take any particular image, suppose you take a medical image, for this medical image now you collect features, then it becomes, what we can do is you apply the deep neural network like this. I will show you some sample images, just wait. I hope everyone can see this. This is a liver cancer data. Can you see the liver cancer data here? Jayshri, can you see the liver cancer data?
Yes, sir. Yes, sir. It is visible.
Okay, very nice. So now this data, this the first layer is there. Now this is normal. All are normal images. You can see here. These images are there. Now these are all abnormal images. Okay. So these are we will attach for this as a label as 0. For this we will attach label as 1. Okay. From these images, what we can do is you can see here. See, basically, but the data set was initially very small. Okay, then in the pre-processing step what we were doing is same data set we were dividing into various you can see here, then we divide each data set into 4 parts, you can see here. So to increase the data set size, this is what we have done. So you can see here, suppose you see here there are various, let's see, ultra liver images. If you have liver images, what you can do is you can partition the data. Okay, you apply partition. Once you partition the data, you can apply, suppose there is a training data and testing data. Once you have training data, this is the most important step. This is called feature extraction. From the image you can collect some features like Gobar transform, there is something called GLCM, there is something called GLRLM RM. Okay, okay, there is a run length matters. Okay, global run length matters. You can apply all these kind of features, you can collect all these features, then it becomes a numerical data. Once it becomes a numerical data through features, then you can send it through see, this is what is the feature extraction step. So GL's grayscale concurrence matrix, then grayscale run length matrix, then Gobar feature extraction. By collecting these features, it becomes like 37, 39 will come. Those features you can give it as a input. Those features you can give input to the deep neural network, which is very easy. That is one step, please understand. Or what you can do is, there is one more, there are two types of methods are available for the deep learning, please understand. What we have done right now is, given image we have taken, we collected the features, those features we can give to the deep neural network. This is also deep learning. There is one more method is there, that is called, directly you give this input to the convolution neural network. There is something called convolution neural network. What it does is, it will take a convolution, it will take a particular part, and that particular part will be keep moving particular image by through filters. Then after applying that various steps like uh, then you will have convolution operation, isn't it? Then after that you will select one pooling, max pooling layer, and all these operations. Then finally it will convert into one particular vector. Then you will apply the again normal classification algorithm. Then you will do the back propagation. Then you will get the change the weights of the filter. So in the same way you will apply convolution neural network. So directly you can give input, also input to the image, also give input to the convolution neural network, that is also deep learning. From the image you take the features and give the features also to the input neural to the neural network, that is also deep learning. Okay, I hope you are understanding. So once you give these features, then you can collect various results. If yours is experimental, then you can see how those algorithms are working. Okay, how those results are working, those are all things you can see. Okay, um I want to show you something else. Wait. Okay, so this is one thing I explained you about deep neural network. Basically, once you know how the training happening with the back propagation algorithm, uh, then all the algorithms, you take convolution neural network, you take deep neural network, you take auto encoders, you take any of these things, basically so the same back propagation is being applied everywhere. Only the thing is, architecture is being changed. I told you, whenever you study a new algorithm, you need to study always the architectures. Okay, to study the proofs of this back propagation, the theory, some other time I will explain you people. Okay, because that needs
Sir,
little bit some more time. Hello.
sir,
Yes,
your screen is not visible, sir.
screen is not.
Have you said anything?
No, I'm just yes.
Okay, okay, sir. No, thank
Okay.
you, sir.
So the derivation of the back propagation. Okay, it needs some more time, so that is the reason I will explain you later for you people. Okay, so right now I would like to complete it. There is something called recurrent neural network. Okay, here what happens now, see, I shown you people, there is something called when
So
you
one question is there, sir.
yes, yes,
Excuse
yes.
me. Sir, what is the difference between the convolutional neural network and a recurrent neural network? Main difference is?
Oh, that is the question.
Okay,
Okay.
yes, sir.
Okay. First, let me explain, complete the recurrence neural network, madam. Then at the
Okay,
end,
okay,
I
sir.
will
Huh.
I'll answer,
Okay,
madam.
thank you,
Sure,
sir.
madam. Thank you. See, what I explained you already, you people. When you give the input, right? There is an input here, and you are generating another vector at the hidden layer. Correct, na? Now, what is in back propagation? What we are doing? If you look at the back propagation, na, zero point 0.4 minus 0.7, and you are giving the information at the hidden. That hidden value is again sent to the output. Correct, na? Then from there you are updating the weights here, from there you are updating weights here, so this is how this is happening. Correct, no? So this is, so it is basically like a forward, all the information is going to the forward because the algorithm is back propagation, you are updating the weights in the backward. So this is how this is happening. Same, so but in convolution neural network, no, please understand, your convolution neural network also exactly works like this only. Here you will have an image and you will apply convolution operator, then after that you will apply max pooling operator, isn't it, through filters. So instead of here we call them weights, no, there we call them filters. So using filters you will get the information here, max pooling, then finally you will reach to the output layer. There also information, there also information, there also information goes through left to the right. So in this input layer to the output layer information will go. Correct, now. So here what is happening is, when you are having the output, see, please understand, but in the recurrent, what is called recurrent, the most important thing here is, I told you earlier, when you give input zero point 0.4 minus zero point 0.7, na, you are generating one hidden neuron layer, that is 0.47 0.45, na. This information, basically this information is the relationship between input and the hidden. This output again we are giving to the input. This output now we are again giving to the input. So if I give 0.47 minus 0.45 to the input again, then what happens is the question now. So please understand, hope everyone understood. It is same like this. See, let me explain you. See, suppose you have a mobile with you. Okay, you have a mobile with you, you are sitting. Okay, and 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 I gave you to understand some concept, I gave you some concept. What will you do? You will study first line of the concept. Suppose you do not understand anything, what will you do? Again you take that particular special term, again you want to try to understand that particular term. Now suppose you are reading about that particular term in the internet. Again you want, if you do not understand some particular term, suppose you are studying about a plus b plus c. Suppose you don't understand what is b, you will study about what is b, then you will study about what is c. So indirectly what is happening, you are going into the depth and the depth and the depth and depth and depth, you are understanding. So basically you are actually, please understand, in the deep neural network, no, if you want to understand a, again you are understanding something else, again you are understanding something else, again you are understanding something else, you are going to the depth now. That is what is happening in the deep neural network. Okay, but suppose you want to understand this recurrent neural network, na, recurrent neural network is like this. Please understand, this is the most important thing. Suppose, see, please understand, suppose you know that today's temperature, you know. Okay, suppose today is what day? Today is, suppose uh, today is Friday. Okay, suppose I know today's temperature. Okay, today's temperature is 30 degrees. Okay, from the today's temperature, and I will give some environmental parameters. Suppose here I gave today's temperature and that is the input, and here I gave today environmental ka humidity. Okay, today humidity and temperature I gave. Then from this what I will do, this I will send to the network. I will get the some information at the hidden. That means what, that information is the combinedly. So you see here temperature is also going here, and this what is this called, your humidity values are going. So this basically captures the relationship between the temperature and the humidity of today's, and it will give you the output here. That output is basically the tomorrow's temperature, correct? So relationship between today's temperature and humidity is already kept in this hidden values, and with that you are generating the tomorrow's temperature, correct? Now basically in the recurrent neural network, if you want to predict the day after tomorrow ka, suppose, please understand, if you want to predict the day after tomorrow the temperature based on today, that means today is Friday, I don't want tomorrow Saturday ka, I want Sunday ka also. Then what I have to do, I have to give the information of tomorrow's also, correct na? So instead of doing that, what I am doing is, this hidden values are there na, hidden values already having information of the today's temperature, and this one na, that information I will use, and the this output also I will use. Then what it will happen, that means this hidden values I will send, that already contains, and that already contains the today's ka information, and I will give the uh, predicted tomorrow's ka temperature. I am already have tomorrow's ka already temperature I predicted na, that also I will give. Then this what will happen, now you see here it is like this. If you look at the recurrent neural network, you see here input is given, then you are getting a recurrent, this is a recurrent block. Again the output loops back to the input, again the same, because basically in the, if you want to predict the tomorrow day after tomorrow's temperature, the process is same. That means the same function is being called again and again. If it is just like a recurrence relation, it is like a recurrent, that's why it is called same block we are going to use again and again. That is what is going to happen in the recurrent neural network. Again we will use the same back propagation algorithm only, but the most important thing is the output generated at the hidden neuron, again you are giving it the input. That is what is the happen. Now there are so many types of recurrent neural networks are there. The basic recurrent neural network is just one to one. You see here, there is an input, there is a hidden layer, there is an output, simple, this is called one to one. But there is one hidden, another type is called one to many recurrent neural network. What is one to many? Is like this, just now I explained, you know, you give input and the input goes here, input goes here. No, please, no, please understand, the input goes here, with this you will generate the output. But this, that whatever the hidden it generates na, for the second block na, when for the second block no, whatever hidden it generates also we will give, please understand. With this it will generate the output, please understand. Again the next one, so in this way keep it the recurring. So you see, similarly this is many to one, similarly there is many to many. Many to many means you will give the, suppose these are all basically used in the language translation. Language translation means, suppose I wrote one word like that key, I, suppose this is here, I take tea. I want to translate these three words into some other words. Suppose like मैं चाय लेता हूँ, something like that, one English to Hindi. Basically, this is a sequence to sequence. It is like when sequence will be there when there is a time. Okay, so always remember, recurrence when the given data contains sequence kind of data, that means it is time related data. Always you use the, for the classification of time related data, you use the recurrent neural networks. Okay, so it is basically, it is like this, one to one is like this in one picture, one to many is like this. Okay, now similarly this is called many to one. Okay, this is called many to many, either this is also called as many to many. Okay, so these are all various types of architectures. In all of these things we are basically using this back propagation only to train these networks. Okay, I hope everyone understood this. Madam, this I'm closing the session with this. Okay.
Yes, sir. Yes, sir. Hello.
Hello.
Yes, sir.
Yes.
So, I would like to thank Dr. Venkatnaresh Babu to giving a informative talk from the grassroots only. So it is very useful for the students as well as the faculty member who are starting their research in deep learning. So, sir, thank you very much for accepting our invitation within so much of short notice period. Thank you, sir, very much.
Okay. Thank you. Thanks a lot.
Thanks.
Okay.
एंड कॉल फॉर एवरीवन हाँ होगा ना